Hello.
Hi, can you hear me?
Yes, yes.
Great.
Um, I'm I'm wondering if there's a way to join the audio with a phone. Do you know which number should I dial if I want to join this with a phone?
I believe there is, but I'm not sure how. I
Okay.
think when
Let
you.
me just spend 1 minute to try to find out if I can log
Okay.
in. Just. Uh, oh, I see it.
Mm.
Hello.
Hello. Can you
Hello.
hear me now?
Yes, yes. Good, good.
Okay, great. Cool. So, hey, I'm Robbie. Um, just to give you kind of idea how this is going to go, we're scheduled for, or sorry, we're not scheduled. Sorry, I'm going into my like normal work interview script. No, we've got, we'll
Right.
probably spend around 40, 45 minutes here. Expect to wrap up about 15 till the next hour.
Okay.
I'm just going to ask you, we'll talk a little bit about your experience. I'm going to spend most of the time just asking you some technical problems. So
Okay.
for these, feel free to use any language you're comfortable with. And
Okay.
cool. So just to get started, um, can you maybe tell me, and this is anonymous, of course, so don't if you don't feel comfortable answering anything, name why, or sorry, if you're worried about an answer giving away who you are, you don't have to answer. That's fine. Um, but if you can, I would love to just hear about maybe, what is the project that you're the most proud to have worked on and why?
Oh, wow. Actually, that's a great practice because I have a actual interview coming up, and the company is known to ask a lot of um, behavior questions. So I talk
Okay.
about one project I'm proud about.
Hmm.
Okay, this would be a virtual reality experience. So I was taking this online program that teaches you how to make a game in virtual reality, right? And then there was like a course project which asks you to make like a boring maze, which has certain mechanics like you can move around, you can collect keys and enter doors. And then I decided to make a creative experience by telling a story using lighting, audio, and special effects. So basically, what I made is a horror experience, horror themed experience, right? So the user is loaded into a maze at a very relaxing afternoon, and then after a few minutes, the sun goes down and everything starts getting creepy. Like the environment is like an art gallery, and there are a lot of like creepy paintings from artists like Picasso and Salvador Dali. And then there was this special effect. So when you look at some painting for over a few seconds, they turn on fire like randomly, and there are women's laughter and children's crying, and then like eventually you're like given instruction about how to escape the maze, and then you're lead on top of a tower, and then suddenly an army of burning zombie approaches your position, and then once the zombie comes close, you're pushed behind from the tower, and then you're dead. And after you're dead, you're loaded into like some kind of after death heaven, where it's a very like beautiful beach. There's a beautiful girl in bikini waiting for you. So that's kind of the how this goes. So I'm proud of this because I made a boring, very boring like course assignment into a very um, creative experience. And right now, this app is published on Apple Store.
Oh wow, interesting.
Yeah.
Cool. Score any extra credit for that?
Oh, extra credit, right. This is like not for school. It's like an online program. I
Okay.
like my project was actually named like nominated the best student project for that cohort. So yeah, that's extra credit. Yeah.
Very cool. All right, cool. Well, let's go ahead and let's start with a technical problem here.
Okay.
So, cool. All right, so we'll do Python comments here. All right, so to start with, are you familiar with the concept of a palindrome?
Yes.
Okay, great. So what I'm going to want you to do is to write me a function to start with that checks for very strict palindromes. So the function should accept a single input, which is a string. It should return true if the string is a palindrome, false otherwise. And this is just a very, very strict character-by-character comparison for now. So for instance, if we passed in race car, it would return true. If we passed in, say, cat, right, it would return false. But also, if we passed in, say, a race car with a capital letter in it, it would return false as well, because each individual character needs to precisely match the character on the other side of the string. Does that all kind of make sense?
Yes. So basically, we can do a two-pointer thing. Left is the beginning of the string, right is the end of the string, and then each iteration we check if the two character equals. If they're not equal, return false. If equals, move left to the right, move right to the left. We keep doing that until two-pointer cross. If by the time they cross, we are still not returning false, that means it's true, right?
That sounds good.
All right. So I just code this quickly. Palindrome S. So while they're not cross, so if S of the left not equal to S of the right, otherwise, yeah, let me just check. Two-pointer, where they're not equal, return false. Otherwise, okay, I think this works.
Okay, good. What would be the runtime complexity of this?
Linear time, constant space.
Okay, great. Cool. So for the next part, I'm going to ask you to do the same thing, right? Basically the same function. But this time we're going to extend its functionality a little bit. So this next version we want to ignore case, and we also want to ignore anything that's not an alphabetic character. So this new version should accept palindromic phrases. For instance, a man, a plan, a canal, Panama, right? In this case, we would still want this to return true, because if you ignore the case, if you strip out all the white space and the punctuation, this does in fact work out to be a palindrome.
Okay. Ignore any non-alpha character, right?
Correct.
So we can just like pre-process the input, right? So first everything to lower. Oh, actually, no. We're just doing one pass through the string, right? So if a character is alpha, we convert it to lower. If it is not a alpha, we ignore it. Oh, actually, no, because we have to preserve the space, right? Okay, let me.
So space is also discarded.
Oh, a space is also okay. So space discarded. Yeah, it actually doesn't matter. So we just go through the string once, convert every alpha to lower, every non-alpha we ignore it. We have a processed input. We just put that into the first function, right?
Okay. And let's go ahead and write a second. I'll call it is palindrome 2 here. And you just want to go ahead and take over from there.
Yeah. So this will be still linear time constant space. Okay. So want to do sys proc. Maybe you want to do a list first. So for C in S, if C is alpha, if it's not alpha, we continue. Okay, if it's alpha, we add lower to the proc, and then once we're done, we join this, and then we just do okay.
Cool. So this should work fine. This is still going to be a linear time, like you said. What is the memory usage of this one going to be?
Linear memory usage, because
Okay.
yeah.
Cool. So for a final version of this question, do you think that you could write a solution that does the same thing as this function, but uses constant memory?
Yeah, it basically has to be two-pointer again, but just be smart about how we move this around. So let me just try to consolidate this logic, right? Still have a left, have a right. So basically what we can do is that have a left on the right and the right. So while this pointer is not pointed at the alpha, we just keep moving it toward the right direction. For example, in the beginning, like the right is at a exclamation mark, we can move it to the A. So because this is at the alpha, it stops, right? So same thing is like when left is moved out of A, so we have a space. We should like keep moving it until it hits man. So yeah, so basically this is it, right? Ignore the no alpha with the while loop, and then do the same thing as the first one.
Okay, that sounds good.
All right. Okay, so while we're doing this while loop, better check this is still true. And left s left is alpha is not alpha, right? So out of this, either they are cross or L is alpha. Okay. Okay. If they're not cross, okay, if they're not cross, and if they're not cross, then if as L lower, oh, the requirement was we convert the uppercase to lower, right? We ignore the case, right?
Correct.
Okay, lower not equal to we're done. Otherwise, what we do? Yeah, we move it. That yeah, it doesn't matter if this out of this at the line 40 if it's a valid character or not. If it's not valid, the next while loop will move this along to the correct character. So okay, let me just check the logic once again. If it's not alpha, I'll keep increasing. R keep decreasing. So here, they must point at both alpha. If they're not equal, return false. Otherwise, keep moving. This will set to correct position. Yeah, that looks good to me.
Okay, yeah, I think this is good.
Yeah.
Cool. So the runtime is still going to be linear, no extra memory, so I think we're good. I'm going to just go ahead and kind of push this down to the bottom of the screen, and we'll start back up at the top here with a new problem. So this one, I think we're going to do a linked list problem.
Okay.
So let's go ahead and say, I'm not super familiar with Python classes, but let's say that we have a class called node, right?
Mm-hmm.
And we're just going to say that within each instance of this class, we're going to have three members. We're going to have one called data, which is going to be an integer. I think I would normally do this in like a constructor in Python, right? But I'll let you assume the correct definition, right? Each node is going to have data, which is going to be an integer. It's going to have a next, which is going to be a pointer to the next node. And it's going to have as well another member called random. And random is going to point to any other node in the same list. So to give you an idea of what one of these lists might look like, right? Let's say that we have a list where the next pointers point from 1 to 2 to 3 to a nil at the end, right? Mm-hmm. The random pointers within this list, on each node, they can point to any other node in the same list. The only constraint is that they will not be nil and they will not point outside of the list. So the random pointers have no rules. They can have cycles, they can be self-referential, you name it. So okay. For instance, in this list, we might say that the random pointers go from maybe from 1 to 3, maybe from 2 to itself, and maybe from 3 back to 1, right? So your goal is going to be to write a function, which we will call deep_copy. It's going to accept the head node of one of these lists, and it's going to return a deep copy. So for instance, if we pass that original list into this function, its input would be the head node of the list, right? So we'll call it node 1. The output would be a new list, which would have nodes, we'll call them 1 prime, 2 prime, 3 prime, and then nil at the end. And the random pointers within this new list would go from 1 prime to 3 prime, 2 prime to itself, and of course 3 prime back to 1 prime. Right, so we copy both the data and the relationship of the random pointers between the data. Does that all kind of make sense? Any
yes,
questions?
Yes. One question. You said that the random pointer will not will have two restrictions. One is not pointing anything outside of the list, and another one, I didn't get it.
It will not be nil.
Be nil?
It will not be nil. It will always be defined.
Oh, it will not be none. You mean that, right?
Oh, right. Not sorry.
Okay.
Python.
It will always be defined. Okay, I see. So yes, I think we can do one thing. Like we can first iterate through these linked lists, ignore the random, right? So while we're doing this, we just create whatever we are currently at and then move on to the next. We put every node we create in a dictionary, which maps the key to the node object, right? And then after the first pass, we can do the second pass. And then the goal of the second pass is just to connecting stuff, right? So from say original at the original node, like we know like node one is point to some random thing. So we can just get the key of this two and then using the dictionary to connect the things together, because in a dictionary we have reference to the new object, right? So
Okay.
two pass linear time, constant space. Yeah.
Okay.
Right. Would you like me to start coding?
Yeah, go ahead.
Okay. So we have the node. Mm, okay, this is the node, and then
And just to make a small change in this definition here, let's go ahead and call this data.
okay.
So this isn't necessarily a unique key. It's just it could be any value.
Oh, it could be any value.
Correct.
Then there'll be problem for my algorithm, because in a dictionary, I use the key to identify the object. If two nodes have the same, so we're not allowed to have a key in this node. Only data,
Correct.
which is not
Yeah.
unique.
Yeah. So the data, there could be duplicates in between nodes.
Okay. Mm. Okay, then my algorithm will not work. I'll have to think about a new way. So the problem with this is data is not unique. What about when we are iterating through the list, we create the random, the node that random pointers point at while we are doing the iteration? Mm, yeah, we can create it.
So so do keep in mind that multiple elements could also share the same random pointer.
Yes, that's what I'm thinking. So, so because the data is not unique, so there's no way to differentiate if this is already be created.
Right. So let's dig in a little bit more on your initial idea. So you initially wanted to create a map from the data to the new node, correct?
Yeah.
But each individual instance, it is a unique object in memory, right?
Yes.
So could we perhaps use the object itself as the key?
Okay. Let's see. Yeah, we don't need to use the data. Let's see. Mm, so if the object is a key, then what is the value? So basically, value can be none, can be anything. Like value basically does not matter. Okay. In that case, we can do this and then done that. Mm, Oh, I see. We're using the original linked list just object as key, and then the copied version as value. That will work. Okay, I see. Okay. What is the nodes? Nodes is maps old node to copy node. Okay. So current is head while current exists. New node equals node current data right. Okay, current data, and then have node just storage which maps currents to new nodes. Okay, and then we have current equals current next. Out of that, we're done here. And then we're doing another pass, connecting everything. Okay. We know that current is connected to current next. So we have to do storage currents, which will take the copied version, dot next equals to storage. Current the next. Yeah, the current next is copy, right? We'll have current dot random equals to storage current dot random. Yeah, we have to return the new head.
Yeah.
We can do response. The first one will be the new head. So if the response is none, response equals the copy version of the original head. Okay, let me just check the logic. The storage maps all node to the copy node, res is known, current head, current new node is in the beginning it's the head, res equals known, res equals new node, storage currents equals new node, current dot next. Okay, and then currents dot next, copy nodes next equals to the original next copied version. Okay, I think this looks good to me.
Okay. And just one small thing where we need to return a value.
Oh, here, okay.
Great. And there's just maybe one small little bit of cleanup we could do. So you have kind of a separate variable that you set for the return value. So the return value is the new version of the head, right?
Yeah.
Could you maybe derive that from the data that you already have stored?
Oh, yes, I see. This is not necessary.
Okay.
Okay.
Oh yeah, I wouldn't worry about trying to run things. We're not trying to get the syntax perfect. Okay. Well, it looks like that's just a missing colon. Okay, cool. So what's the runtime complexity of this one?
Linear time, linear space.
Okay, great. Let's see here. We've got a little bit of time left. Let's go on to one more problem. So for this one, we're going to do another linked list problem. This time we're going to have a node class that is a little bit more simple. So this one is just going to have self.data equals data, and this one's going to have a self.next equals none. So this is just going to be a simple singly linked list. Each node in the list has it has an integer for data, it has a reference to the next node of the list, and it has none when we get to the end. So your goal is going to be to write a function which accepts the head node of one of these lists and prints it out to the screen in reverse order. So for example, if we have a list that went 1 to 2 to 3 to none, you would want your program to print out to the screen 3 and then 2 and then 1, right? Each on its own line. Any questions about that?
Yeah, no. So we can do is we have a reverse method, we have a print method. The print method is just going to print the linked list from the beginning till the end. Reverse method is going to reverse a linked list. So we will first reverse the current linked list, and then we print the list, and then we reverse it back. So the reverse method is a linear time. So this will be linear time and constant space.
Okay, that sounds great.
Have a reverse. We have tell. We have print tell. Tell. Then we will have to reverse again. Head equals right. Then we'll do print this head until none. So maybe okay. While current is not the end, we should current data, and then current equals current next, and then actually we should return. Maybe you should return. It's better. Drawing out the response and we can print this. Okay. And then we have reverse. So we can do is we have a previous, we have two pointer, previous and current. Previous equals none. None. Current equals heads. Okay, while current is not the end, we get the next equals to current dot next, and then we will have current.next set to previous, and then previous equals current equals current.next. In the end, the current is none, previous, right? So just do a test run in line 20. Initially, we'll have this. So first, we set the 1 point to none, which is previous, and then we move this along. C is here, P is here, and then we set this to this, and then we move C here and P here. Then we move this, and then C is none. P is at 3. We return the P, so we reverse it.
Okay. So conceptually, this is correct. But let's do that test run again. But let's just take it line by line and look at very specifically what what each line is doing. So we'll start with previous and current, right, set to none and 1.
Yeah.
So if you could just take me through this functional line at a time, and let's those pointers at each line.
Okay. So right now we should have the next, right? Next. Right now the next next is pointing at 2, right? So current next is previous. So 1. No. Current dot next is like current dot next is pointing at none, right? Because so we said okay. So after this, we have a next point at 2, and then this one we just set 1 to point at none, right? And here we previous move to current, which is P point at 1, right? Yeah, and then current equals. Oh, I see. Cannot be next. Current have to equals to next.
There we go.
Here we go. Yeah,
okay.
Because I already changed the next. Yes, I see.
All right. So this should work. What is the runtime complexity of this going to be?
Runtime is linear. In here, I'm returning this string, right? So if I'm not returning, it kind of have to be constant, because while you're iterating through it, oh no, you don't have to do it. You can just print it out.
Right.
Yeah. Yeah, I don't know how to print without a new line. So if we can print without a new line, then this will be working. So
yeah, new lines are fine.
Yeah.
Okay.
Okay.
All right. So I think we are. I think we're good. This is the optimal solution. And we're kind of coming up on our time limit here, so I think I'll go ahead and stop there.
Okay.
Great. So I'm going to go ahead and fill out feedback for you. Is there anything in particular you had questions about that I could answer now, or you just want me to kind of fill out?
Yeah, like if it's a real interview, from a rating of 1 to 5, what kind of score would you give me, and how can I improve?
Sure. So if I do a 1 to 5 scale, probably like 4.5.
Okay.
If this were like a real phone screen, the rating that I would give is a strong recommendation that we go to an on-site. Basically, you did very well in the problems. The only real hiccup that we had is when you came up with that idea for the deep copy. You just needed to realize that you could use that you could use an object as a key in the dictionary.
Yeah.
So that's something to watch out for when you use kind of a higher level language. Just make sure that if you get hit with, for instance, like a problem that involves moving pointers around a lot, right? Like make sure that you know your language's particular semantics for like finding the ID of an object or, indexing by a class, that kind of thing.
Yes.
But
Yes.
aside from that, that was the only hint I really had to give you. You had a couple of very small errors, but all the other very well put together. So that would definitely be a recommendation for an on-site for me.
Okay. Okay. Cool. Here's one last question. This might be too much to ask, right? So currently, I'm a third-year undergraduate student. I'm looking for internship at a top-tier company. If you happen to work for one of them, I'm just wondering if you would be willing to give an internal referral for internship application. Like I know this platform making money like uh, by getting people hired, but my case is really internship, and the platform does not deal with such hiring. So what I'm asking is not does not like harm the platform's interest if you're concerned about that.
Gotcha. So I probably shouldn't because I tell you what, let me actually ask so this is actually the first one of these that I've done. So I know for a fact that it's going to get reviewed. So let me just make sure that I ask them that that's okay and it won't get me kicked off the platform before I give you an answer.
Okay, you can like tell them that basically I have asked them about like getting hired through a platform as internship like applicants. They said they don't do that, so I think this is will not be a conflict of interest. But of course, like you can check with them. But in the event that they say it's okay, like please like uh, uh, like is there any way like to get back to me? Maybe we can do this introduction thing. Like we can
Yeah, I
mark
believe
up. Okay.
yeah, I believe that's an option. So I will
Okay.
check them and find out.
Okay. Cool.
All right, great.
Right.
Well, thanks very much for your time and have a great rest of your day.
Okay. Thank you very much. Bye bye.
All right, bye.